Good morning everyone, welcome to this Advanced Steel webinar where we're going to be looking at working with timber in Advanced Steel. Just before we get cracking, could someone confirm via a question that you can hear and see me okay? Okay, I've had a couple of people confirm that you can hear me. Okay, so that is good. We'll crack on. So my name is Rob. I'm one of the application engineers here at Graitec. I have been working in the steelwork and metalwork industry since I left university. 7 years of that working as a draftsman, as a subcontract draftsman in two different subcontract drawing offices, and then the last 2 years has been working at Graitec. So my primary focus with Graitec is training, support, customization and implementation of advanced steel. But in the last 6 months or so, as most of you know on here, we're now looking at all aspects of the AEC collection for steelwork. So if you've got any questions relating to today's webinar or any other webinars that we've done, or just anything at all, my email address is there, and I'm on LinkedIn and Twitter as well, so you can reach out to me. We're here to help you guys. So we'll just have a look at the webinars that we've got coming up. This is the first webinar in this sort of mini series, this mini run we're doing. So today we're going to be looking at timber in Advanced Steel. Next Monday at 10 in the morning, Alec is running one on concrete stairs and railings for concrete stairs in Advanced Steel. And then in the afternoon, he's going to be running a webinar on custom connections within Advanced Steel. So two really, really good webinars there. You'll pick up lots of tips and tricks on those ones. Then I'm going to be looking at the Revit and Advanced Steel 2020 updates for steelwork. So some of the new tools in both systems and the imports and exports in the 2020 versions. And then John is going to be doing two Plant 3D in Advanced Steel webinars. So the first one is going to be Plant 3D elements in Advanced Steel as standard parts, and then the second one is going to be looking at Plant 3D and Advanced Steel collaboration. I think I've got the date wrong on that one. I don't think it's the 24th of June. I think it is the 9th of July. I have attached this presentation as a PDF handout. If you look in your handout tab, you'll see there's two handouts in there. So the first one has got this PDF with all of these links embedded. So you just click on the link, it'll take you straight to the registration page. The second handout is a PDF that's got all of the structures teams recorded webinars from the last couple of years, because we get asked quite often for the previous recordings. So every webinar that we've done in the last couple of years is on the other handout. If there's anything else you need regarding the webinars, just reach out to our marketing department. So today we're going to, like I said, be looking at timber in Advanced Steel. So we're going to start with structural timber, what we can do with that and where it is and how you can model it. Then we're going to look at custom connections for structural timber. So I'm not going to go into too much detail on the custom connections because Alex is going to cover that next week in his webinar. I'm going to show you what we can do with them. Then we're going to look at the packing of steel beams, and we'll quickly have a look at the drawing output and a couple of customized drawing styles that I've done for timber packing. And finally, we'll move on to timber for architectural and metalwork. So we'll look at what we can do with stairs, railings, and balconies. That's just jumping ahead a little bit. So we will crack straight on. So by definition, Advanced Steel is a steel detailing package, but we can detail a lot more than just steelwork. In the past, obviously some of you guys model glass out there. I've modeled entire structures made out of GRP sections. So Advanced Steel is a hugely powerful tool. It's almost just like anything that has been fabricated, we can model it and we can produce drawings for it. So today we're going to look at some timber sections. So there is already a library of timber in Advanced Steel. If we go to the Objects tab and we click the little drop down here, we can see that there is actually a timber beam function. So this will draw a timber beam in the model. Now the behavior is slightly different. If you see on the dialog, there is no coating, but in here, if we go to the all, there is a timber sections category, and we've got glulam in there, we've got solid wood cross section, stock square timber, timber cladding, and timber purlins. And then within there, we've obviously got, if we look at the glulam sections, we've got lots and lots of sizes. Now, if there isn't a size that you want in there, we can add it in via the databases or as user sections. We're going to look at user sections in a little bit. But generally, the options for timber beams are the same. We can apply model roles, so we can get drawings out of it. I will explain the difference between modeling it as a timber beam and just a steel beam and changing the materials, because sometimes you want to do different things with them. And what I've had to do in the past, I have worked on projects where we've got structural timber and structural steelwork. So in this little example, we're going to just use this model view just to isolate my structural timber. We've got some hot rolled box section columns, so some steel columns with a glulam beam. So I need to put a fin plate connection in there, and I need to put a plate between. I've got a 140 glulam column in here. What I need to do is we need to create a slot in the top of this beam and a slot in the column for a plate to sit in, and then that one's not actually going to be bolts, that's going to be timber dowels that go in. And then the final bit is we want to put a bought-in shoe with some resin anchors into the bottom of this column. So I would, if I'm doing this and you're doing a lot of this, I would start to set up custom connections for this kind of thing. Because if we look in the connection vault, I can apply, for example, a fin plate connection between the column, if it's going to let me. I can apply a fin plate connection between the column and the beam, but that will put it on the back side. I can't get that within this macro because I can only have left, right, or both. So if you do want one on both sides, we can just use a standard connection. What I want to do, and what I've done in the past, is I want a fin plate in the middle of the glulam with a cap plate on the box section with some counterbore holes. So I'm not going to use a connection from the connection vault. I'm going to use a custom connection. So I do have them already set up. I will open them up in a minute and just go through what I've created in there. But I'll go insert connection template. And there you can see I have a file called timber connections. So I have the SHS to glulam fin plate. So we select the SHS, we select the glulam, and that custom connection will put the cap plate on for me, put the, if I just isolate, it puts a slot in the glulam, it cuts the glulam back to the column as well and puts a 10mm gap in there, but it's also created the counterbore holes for me. So we just bring that back, you can see that the bolts now sit within there, and we've got the fin plate. So that is just a custom connection. Again, we'll put one, we'll go on to the other side. So we've got a glulam column to a glulam beam. So it's telling me at the bottom, select the glulam column and then select the glulam beam. Now what this one is doing is I've again got just a plate on the inside, but instead of bolts, I'm using timber dowels. So I've actually just modeled an advanced steel round bar and changed the material to timber. So it will show up on my material list as a 12mm timber dowel rather than a 12mm round bar. So again, that's a custom connection. You can see that it's cutting both objects against each other, putting the correct notches in there, putting everything in for me. And then the final one is the glulam shoe. So we just select the bottom of the column, and that will actually put the special part shoe in there. So that's just been modeled as a special part, but it will also put the anchors in and shorten the column to the correct height. So custom connections, like I said, I'm not going to go into too much detail for you because that is what Alec is covering next week. The custom connections are stored in your program data, Autodesk, whichever advanced deal you're running, and they are in the shared folder, and there's a folder called connection templates. Now the files must be saved in there because when you hit the insert connection template button, that's where it gets all the information from. So all you do is the custom connection is made up of lots of building blocks. So I've got an end plate connection in here. I'm using a couple of cutter objects. So I'm cutting this glulam beam to the box section. So I think that's that one. That'll be cut, saw cut flange with a 10mm gap. If any of you are interested in the counterbores, what I've done is I've used the building block bolts, anchors, holes on a plate. So that puts the 2mm hole in everything for me. What I have then done is, if I turn the features on in here, I've used, from my features tab, I've used a circular contour. And to get it to go to a certain depth, you use the boundary option. So I've used side 2 and I've said -40. So what that does is that goes from the system line of the beam -40mm, and that's where the contour stops. And if you put the same contour on all 3 bolt heads, the bolt heads will actually jump to that face for you. So if you're working with timber, and it's quite a common detail to have counterbore holes in there for the bolts to sit in, that's how you can go about it. You could probably also go about it using the hole command up here and using a blind hole. That would also work. So that is my structural timber with custom connections. So I don't want to keep you guys too long today. We'll try and keep it to about half an hour, 40 minutes. So we'll move on to the packing of steel beams. So in here, I've got a floor of steelwork with some steel joists, but I'm going to have timber joists in here. So I actually need to pack this web out. Let's just check the distance. There's a couple of ways you can, well, there's 2 or 3 ways you can go about it. We have clients who work with this kind of stuff in advanced steel, and they go about it in a couple of different ways. So we'll run through a couple of different options. So we've got 70 mils worth of packing to put in there. So there's a few ways we can do it. We're going to start with modeling the timber as plate. So what I'm going to do is I'm going to model it manually. So the first thing I need to do is put my UCS on the plate. So I'm going to use put my UCS on the beam. So I'm going to use my UCS at object command, choose the object, and then in here we get a range of lines which show me where the Z-axis is going to be positioned, and that will put my UCS on the object, and we'll just make sure that it's on the actual web. So all I'm going to do to start with is I'm just going to create a rectangular plate based on a center point. I'm going to choose a center point in there. I'm going to position it so I don't actually need to find the middle. I can use these offset buttons, and we're just going to position it around there. We can set the length and the width. We'll maybe say it's 220, and then my timber packing, let's just say we're going to get them in 50 mil. We'll get a 50 and a 20. And all I'm going to do is I'm going to change the material in here to timber. And we'll leave it on timber. You can obviously add extra materials into the system as and when you need them. So that is how I would get one plate in there. Now what I'm going to do, I'm just going to show you guys what you can achieve out of the box, and then we'll change a few things and I'll show you a couple of tweaks that I've made. So in here, I'm going to call this a mounting plate, because that is a model roll that we get out of the box. And then what I'm going to do is I'm going to move my UCS. And we're just going to recreate that, and we'll make this one 20 thick. And again, we'll call that mounting plate. Now to get these to show what a lot of people have told me and what a lot of my clients have done in the past is they don't want to bolt these items on. They actually want to shot fire them. So they just want a note. They just want this to show on the assembly drawing. So I'm actually just going to weld them to the beams, and we'll put them in we'll put the weld symbol in the midpoint here. What I'm going to do is I'm going to turn the weld double to none, and in the additional data I'm going to type in here shot fired at 200 centers, because that will show on my assembly drawing. So that's one way of doing it. We can model them as a plate. Now there is another way you can do that. You can do it a bit more intelligently by using these custom connection building blocks. So we want to use a plate along beam web. So we will choose this beam here. It says, do I want a reference point? So I'm going to say yes. So we're going to go mid between 2 points. We're going to go the node in there and to the mid flange at the bottom in here. That will put me a plate horizontally and vertically in the middle. And then again, what we can do is we can make this one 38 thick. We can make it a meter. Don't want to make it a meter that way, so we want it 200 that way. We can make it 1500 long that way, and then number 5 is the offset vertically, but number 2, if I change that to -750, that will center it again in there. And this one has a create weld option. Now the benefit of doing it this way is A, it creates the weld automatically for you. You can set it up as a custom connection, and again we can just change that one to, we'll say shot fired at 150 centers for that one. Once we've created that one plate, we can then use the plate on plate option to say, right, well, we want to make that plate on plate. The distance layer, I can make it based on projections, and I can say all projections are equal and that they are projecting 0 from the plate we have in there. So then what I have is whenever I adjust the size of this plate in here, this plate will automatically adjust for me automatically. So we haven't got to go in and change the size of the plates. We can set one up and the other one will adjust automatically. And again, we can model these as timber. And we'll put one bit on the end. Now if we're going to do this as a beam element, if I go to the other objects, I don't actually want to use this timber beam option, and I'll explain why. If I put that on there and we draw it this way and we make it a meter, I can model it in there and we can make it stock square timber. We'll make it 100 by 100 and we'll just position it sort of middle flush like that, just as an example. Because it's a timber beam, it won't allow me, when I do my welding, can you see that I'm trying to click it? So a timber beam to advanced steel is a loose beam that can't be attached in the workshop to anything else. So if you're modeling your timber from a beam section, not a plate, you would actually go to the model a manual beam and go to the other sections. Again, we'll just set that up because like any section in advanced steel, it does think it's a steel beam, but then I can weld it, so I can go other profiles, not other profiles, come into here, find a category, timber sections. We'll go stock square timber. Okay, we'll do SolidWorks cross sections instead then, and we'll choose 100 by 70, and then we can rotate that round, position it how we want on there. And there is a layer in Advanced Steel called timber beams. Make sure we set the material to timber, and the naming we will just call this beam. But now, because I've modeled it as the system thinks it's a steel beam, I can, if I choose the right point, I can now weld these two together, and we can just double check. So I just need to create a weld between those two because they weren't all attached. So if I do show me what's attached in the workshop, I have covered all of this tab and checking things on my webinar for checking your Advanced Steel model. So they are now all attached in the workshop. What I will also do is we'll just do some top flange packing on this beam, and then we'll run some drawings. So make that 200 wide, we'll make it 1500 long, we'll make it 38mm thick. We'll make it 140 wide. And we'll just position it there, and again we'll just put a weld in. Now there is a model roll in the system for flange plate. Okay, so we have some of our packing modelled. So what we'll do, we'll number these items. And we'll run some drawings for them. Okay, so we'll just let those run, and we'll have a look what you get sort of out the box, because what you have to remember is the system is treating these as steel items. So at the moment there'll be no differentiation between the timber and the steel. So I have tweaked a few things in the system to give me a few more sections. So at the moment on this beam, it is viewing us from the back side. So I just need to flip that round because my system's set up not to dimension anything that's hidden. But before we go any further, you can see that the weld in there, okay, it is showing the fillet weld symbol, so maybe what we'll do is we'll go back to the model and we'll just tweak a few of these and see if we can. Because I can change the weld to none. So it's not a fillet weld, but it will still show. So what I need to do is I need to change the way that this drawing is viewed. So I'm going to set my UCS up with the X and the Y, and then I'm going to use this button in here, which is Define Assembly Detailing Direction. So that will say View the beam from the front side. So if I come to my drawing and I update the drawing, it will just flip everything around and view it from the other side. So it will actually attempt to it will dimension everything up from the front. So you can see now in here it's dimensioning up some of my packing. Oh, I didn't set the model roll correctly for the mounting plates in here. I just called them plate, but they should be mounting plate because it will start to dimension that. So we'll just update it again. So this is what you get out of the box. what we just wanted to show you today is that these drawings can be tweaked and pushed and pulled to give you what you want, because it's sort of putting the dims at the top here, dimensioning the left hand of some of them at the bottom there, and it's not differentiating much between the steel and the timber. What I've done there, by taking out, I've changed the well to none, and you see now it's just saying shot fired at 200 centers. Okay, so I've created my own drawing style. Again, we don't really have the time today to go into everything that I've done. What I would say is, if you are going to play with any of these drawing styles, I'll take you to the folder location. You must back up your advanced steel before you start this. So we do have a blog written on backing up your advanced steel data, but it's C, program data, Autodesk. I'm running Advanced Steel 2020, and it's the GBR version. If you want to back up every part of your Advanced Steel, if you're running a GBR build, it's that folder there. And the bit you're looking for is under user 2, and it's the asteraddin.mdf. That is where all your drawings are, your drawing styles are saved. So I strongly advise that before you start playing in here, to take a copy of that, because 2 or 3 wrong clicks can mess up all the drawings. I messed them up a few times this morning before actually starting this webinar. What I've done is I have copied the general assembly, and I've called it RM General Assembly. I've copied the front view, and I've called it RM Front, and I've just added a couple of extra rules in here for the timber packing. So what I got my drawing, or what I want my drawing to do, is I want it to dimension the steel items across the top, and I want it to dimension the timber items across the bottom. But it is not going to do it, because in my drawing style I've got particular model rolls that I need it to trigger. So I need to select those plates. So I've added in some extra model rolls because I want it to dimension those differently. So my model rolls are called packing. So I've got packing web, and I've got packing top flange. And the packing, although this is a beam, when I set the model roll up, I allowed it to work for beams and plates. So if we go to all, we can go to packing web. Now what I've also done in this model, I'm just going to renumber these beams because I've set some prefixes up in there, so they're not just called F anymore. I've got them to come out as T, so I've got timber packing, so I've got TP for all my prefixes. So if we come back to the drawing, and we'll just apply my new style. What I've tried to get the system to do is dimension the packing vertically from the top of the beam, but any steel dimensions to plates and holes go across the top now. Haven't quite moved that one just yet, but I've added an extra chain in here that always goes to the bottom of the beam and will always say timber pack, so we can just differentiate between the two a little bit. Now we would probably change your clipping a little bit because it's getting a little bit messy in here with things overriding things, but there is an extra set of dimensions in there which we could take out. I've taken the wrong ones out. I'll take that one out. And we've probably got one too many views in here, so we can just delete these and tidy them up. But with a couple of tweaks in the drawing, we can get things like this to happen, where it dimensions the timber pack and we'll put some dimensions in. And the same with the top flange drawings. Sorry, the packing on the top flange, I didn't quite get this one completely finished. But again, that chain in there and that 1500, so on the front view the 1500 will be taken out and it's just dimensioned on the top view, and it's called timber pack. I've got the extra text in there to say timber pack. So there's a couple of things we can do with drawing styles. If the majority of your work is with timber and is with packing, it is something that either you guys can play with yourself or you can come to us. We do run a drawing styles course to teach you how to do the drawing styles, or we can just quote to do the work for you. It's worth having a play to see what you can achieve. Once you sort of know what you're doing, to achieve this kind of thing where it's the odd dimension on the odd view is not too much work when you know all the acronyms and everything like that. So that's the sort of thing we can do. If you're doing timber pack drawings, we can just start to tidy those drawings up, and we'll try and I would go even further and start dimensioning them on here and tidy a few more things up on these drawings. Okay, so the last bit of today's webinar is we're going to be looking at what we can do with architectural metalwork. So I'm going to isolate with my model views a staircase I've got in here and a balcony. Let's just go to realistic. So what I want to do on my staircase is I want to create a stair with a timber capping rail, so a rail that sits on top of a 40x8 flat bar, and on my balcony I want to actually model the decking. So those two sections don't exist in Advanced Steel, but we can set them up as user sections. So in here I have a timber user section file, and I've created my timber capping user section, and I've created my 140x28 timber decking. So I've generated those sections. I have gone into a couple of databases to allow me to model with those sections. And what I'm actually going to do for the timber decking is I'm not going to model them manually. I could just draw them as a normal beam. So I could just come into other sections and start drawing the decking, and it will go in there. I'm actually going to use the purlin macro. Now the purlin macro out of the box has a few timber items set up in it already for you. So what I have in here is I have a supporting angle at each end of the balcony that timber is going to sit on. So those are my members. I'm going to choose a reference point. My reference point is going to be the end point in here because that's where I want my decking to start from, and I don't want any additional reference beams. Now you might be wondering why I'm starting with the purlin macro, because that is for putting cold form C-sections in. But if we go to the library for it, now out of the box everyone gets timber side rails and timber purlins and timber cladding. So you can do what we in this country called Yorkshire boarding, which is on a farm shed. It's the vertical sections of timber that clad the top half of the shed. You can do that with this macro. What I have set up in here is a 140x28 timber decking. So I've edited one of the databases that allows me to model decking in this macro, but that will put the decking in for me. And because I'm using a reference point, if we go to the alignment, I'm saying for the distances, use the reference point. There's a 140 wide bit of decking. So the first point is half of that, plus I wanted a 5mm gap in here. Now the overhang, if we look at the alignment, I just need to bring back 25mm for each one. And that then gives me my timber decking with a 5mm gap in between, so I can actually model that in. Now it goes and it fits in as many as it can, so we might need one extra bit of decking that they need to rip down on site. So I don't need to break the macro for that. I can just copy one element out of the macro, and it's obviously too big, but you still want to order that. So we still want that to be ordered, and then the guys on site can rip it down to suit. So that's one way of using one of the macros in Advanced Steel to model timber. And again, we do have timber purlins, timber side rails, and timber cladding already set up in that macro for everyone. I've just edited one of the databases, the GUI allowed section database, to allow me to use that timber decking in the purlin macro. The other macro I've edited is the railing macro. So I've edited the database for the railing macro to work with my timber capping. And the beauty of Advanced Steel is once you've got one of these items set up, we can save it in the library so we don't have to go through the whole dialogue like I've just done with the timber decking. You wouldn't want to have to go and set all of that up every time. So once you've set it up once, save it in the macro, and it will always come in like that. And again, because I'm using a PFC channel, I'm hoping will come in straight away for me. Let's just move my model box because we can't quite see the top of the railing there. So what I have in here is, if we go into the joint properties, if we go into the handrail section, the top handrail is made from my timber capping section. So we're going to have a look at the end down there. So there's my timber capping section. And then I have used the middle handrail is my 40 by 8. So this section in here. And I've set that out from the top. And then I've used the distance of just 11 millimeters, which puts it exactly underneath that timber capping. And then the bottom rail is obviously coming down here. And then I've got square balusters in between. So again, that macro will do the work for me. So if I want to apply that same balustrade to my balcony, because I have it set up as a library entry, we can start it there and end it there. That will still use the timber capping. The last thing I just want to show you is you can see in here I've got a couple of queries set up because the system is modeling these as steel elements. So what we want to do is we want to isolate any timber capping that is not currently timber, so that I can select all of them in one go, isolate the beams because it will leave any AutoCAD setting outlines. We can go to the properties in here and we can change it to timber, and that is, let's say that's oak. And then what I'll do is I will just change a layer of these to timber beams. And then I have a similar search for timber decking. So if we look into the properties of the search, I'm searching the model for steel beams because it's been modeled in the purlin macro. The system has modeled it as a steel beam. I'm searching for a material that is not timber, and I'm searching for my 140 by 28, or I'm just actually searching for my timber decking category. And that means that if I have 2 or 3 different sizes, I don't have to set up a search for each size. So again, I can highlight, it will isolate all of the decking in the model for me, and we can just change that to timber and timber. That is about all we have time for today. Does anyone have any questions? If I can't answer it now, I will get back to you. I'll pick up all the emails that come from this webinar. So if I can't answer it straight away, I'll come back to you with any questions that you have. I can't see any questions coming through. And the last little bit in here is we are here to help you. So if you are interested in any of the stuff I've shown you today, we have this implementation roadmap, which starts with the basic training. Then, which most of you have already had, because I recognize a lot of the names on here, is an implementation day where we come and set your initial system up so you've got all your logos changed and things. But some of the bits I've showed you today are step 3, which is documentation training and customizing. So that's the drawing styles. But it can also be setting up all the databases to work with the timber sections and things like that. So if you are interested in any of that, or you just want some help with things, our contact details are in all the handouts. Please reach out to us. I'll keep the webinar running for a couple more minutes. I haven't had any questions coming through, so hopefully you found today useful, and we hope to see you on the webinars coming up over the next few weeks.